everything. All of you keep reading. Applications of Bernoulli's principle. So we're going to study two concepts today. That is what based upon the applications of Bernoulli's principle. So one is Venturimeter, and the second one is speed of efflux. That is what we used to call it as a Torricelli theorem. So what is these two things we are going to discuss in our today's class. So all of you keep reading. Applications of Bernoulli's principle. That is what Venturimeter, and the next one is speed of efflux. That is only we used to call it as Torricelli theorems. Today's yesterday's class completed. Yesterday's class have you watched? When now time permits, you have to finish. You cannot make pendings. Am I audible? Everybody?
Yes, sir.
Yeah. So let us comes to here. So we'll go with the first one. That is what Venturimeter. So what is this Venturimeter means? It's like a device. It's a simple machine which will use to measure a rate of fluid or rate of flow of liquid through a tube. Measure rate of flow of a liquid through a given tube. That is what we used to call it as a Venturimeter. So rate of flow of liquid, that is what we can say is velocity, the liquid amount of liquid moving along across the area of cross section. Understanding? That is only ways to call it as a rate of flow. So this A into V, which is equals to remains, we all know equals to constant. Look at law, which is call it as law of. Please respond. Law of continuity. Remember everybody. So what is this Venturimeter means? So for example, if I consider a pipe or a tube, so across the given area of cross section, let me take this is A. So across the given area of cross section, so let's suppose the velocity of the fluid is moving with the velocity V. So how much amount of liquid is passing in 1 second? In 1 second across the given area of cross section. Across the given area of cross section is only ways to call it as, what is to say? All of you? Rate of flow. So in a given area of cross section, how much amount of fluid is passing across the given area of cross section, which we used to call it as, what is to say? Rate of flow. Do you understand, all of you? So simply if you want to say, so Venturimeter is a device which will help us to measure the speed of flowing liquid. That is what we used to call it as a Venturimeter. So now, in our today's class, we are going to discuss, so what is the Venturimeters? Like what is the applications of Bernoulli's principle in this Venturimeters? So what is the use of it and all, we'll discuss it. So let us take now, everybody. So this is the basic use of Venturimeter, where we will use to measure the speed of the fluid in a given pipe or given flowing liquid. Now let us see what is this Venturimeter, how it will be. So generally, if you notice, Venturimeters looks So how the Venturimeter looks. So this is what we used to call it as basically Venturimeter. So actually with this example, it's a even diagram I want to draw. So with this itself, I can teach you all the concepts. So let me take now, if you consider this is what we used to call it as a Venturimeter. So now if you all let me go with this only. So we'll use this image itself. Why I should draw away. So we'll make it and we'll solve. So this is what basically we used to call it as a venturimeter. Used for what? Everybody, here you can see here. Venturimeter is a device used for measuring the rate of flow of a fluid flowing through a pipe. All of you understand, everybody? So please note it. Anyone having any doubt, you can ask me. Clear? Understand? Everybody? Yes? So now,
Yes.
if you have noticed it, so this is the simplest device which we used to call it as a venturimeter. So now, let us observe very carefully here. So we all studied that if it is a steady fluid, in a given horizontal height, at every point the pressure is remains what? All of you? The pressure is remains what? If it is a steady fluid, at every point the pressure is at a given horizontal level, at every point pressure is remains what? That is what is my question. Everybody? Forgot it? In a steady fluid, the fluid which is that moving, not moving. So in a horizontal level, at every point pressure is remains what, guys? Pressure is remains same. But remaining all you leave from the meeting. What is the use of you people? You people such a waste fellows, you not having any use. But now if you consider here, so this is what we used to call it as a venturimeter. So let me consider this area of cross section is A1 and this area of cross section is A2. So we all knows that from the law of continuity. So what is that? A1 into V1 is equals to A2 into V2. So all of you observe very carefully. If area of cross section increases, then velocity decreases or increases? Velocity decreases. If area of cross section decreasing, then velocity what? Velocity increases. So now, at a given height, let me consider the point is here. So given height, and these are the tubes which we used to call it as a capillary tubes. So which will help us to measure the pressure. So capillary tube. So uses to measure pressure difference. Pressure difference. That is what this capillary tubes used to say. So let me take here, you see that area of cross section is A1, at here area of cross section is A2. Now here the fluid is rising in a capillary tube up to here. Let me consider this height is Y. And here the pressure is rising in this capillary tube is, let me take it as a X. Then what is the difference, guys? What is the pressure difference in this both? Anybody can tell? What is the pressure difference? Let me consider that height is H. So then what is the pressure difference? Anyone can tell? Let me at this point, even they mentioned here, at this point is P1, at this point is P2. Then can you tell me, everybody, what is that pressure difference? All of you? P2 minus P1, which is equals to pressure at here and pressure at here. So what is that? Rho G Y minus rho G X. We have importance of just I'm saying. So rho G Y minus X. So what is the Y minus X equals to something? Anybody can tell? Y minus X is equals to something. Y minus X is equals to what, guys? Which is equals to what? H. So I will remember this. So note it, everybody. P2 minus P1 is equals to rho G H. So let me consider this equation and remember, all of you. I hope you will understand. So now let me consider here the velocity is V1 and here the velocity is what they have given at this point. Velocity is what? V2. Note it, this point is belongs to here. Don't think that here they mentioning the arrows you see. Okay. So here V2. So now if you observe here, so what is the Bernoulli's equation? Anybody can tell? All of you. Bernoulli's equation, please. Bernoulli's equation, please. Bernoulli's equation, don't know. Such a condition you people are. I want Bernoulli's equation. Yes, please.
P1 plus rho.
Yeah, tell me. Bro. So P1, we are having 2 points, P1 and P2. Yes, please respond. P1 is equals to P1 plus, speak.
Rho G H.
Rho G H1 half into rho G
V1.
Half rho V1 square.
P1 square is equal to P2 plus rho G H2
Rho G H2 plus half rho
rho G into V2 square. Am I right? Now, All of you observe very carefully. This is the first point and this is the second point. Both are in the same horizontal line from the ground. If I take, suppose if this is the ground, let me consider. And this point, both are in the same height. This is H1 and this is H2. So both are same height. So I can say both H1 is equals to H2. So what will happen? Both are equal means then this term will become 0 and this term also will become what? 0. Why? Do you understand everybody? So H1 is equals to H2. So means same height. So from the base. Same height from the base. Are you clear everyone? Understand brothers? So that the both the terms will be vanish. Yes or no? All of you? Yes. That is what. Next. Let me take it now. So what is remaining? P1 plus rho, half into rho V1 square is equals to P2 plus half into rho V2 square. Now, all of you observe very carefully. So this one I'll write it P2 minus P1. Okay. P1 minus P2. So let me write here also. I have done mistake. Something I think. Yeah, pressure here high and here low. So here P1 is high, P2 is low. So P1 minus P2, P1 minus P2. So please write it. Okay, now understand everybody. So y minus x rho gh. Okay, Rudresh. So now P1 minus P2. So P2 will come here, it will go here. So what is the equation will come? Anybody? P1 minus P2 is equals to half into rho into V2 square minus half into rho into V1 square. So now both rho is common or even half also common. So half into rho into V2 square minus V1 square, which is equals to P2 minus P1. So just now we studied P1, P1 minus P2 is equals to something. What is that everybody? P1 minus P2 is equals to something. What is that? All of you. P1 minus P2 is equals to how much, guys? Rho GH. So rho will get cancelled. So what else remaining? 2 will come this side. So 2GH is equals to V2 square minus V1 square. Will you all agree with me, everybody? Yes, please. All of you? Please respond. So let me consider this is equation number 1. Any problem for anybody till here you ask me. Understand, brothers? Rudresh? Clear? So we got it. 2GH is equals to V2 square minus V1 square. Now, from the equation of continuity, I'm continuing here. Any doubt, anybody can ask me. From the equation of continuity, what is the continuity equation? Anybody? A1 V1 is equals to A2 V2. Yeah, from that I will say, can I say V2 by V1 is equals to A1 by A2. So till here, anybody having any doubt, you can ask me. Understand or? Please respond. Yes. So let me take this is the two equations. So from here, I will go to the PDF, Word document, and I'll cite there. Till here, anyone having any doubt, please kindly let me know. I'm giving 2 minutes time. So if you have any doubt, you can ask me, or else I'll proceed further. Everyone, I'm saying. Somebody called to Mr. Murali. Murali is there? Murali, yesterday you were absent. Today what happened? Today you were there. Mr. Narayan, somebody called. And Princey also. Be sincere, Murali. No progress at all in studies. Father is worrying like anything. Everybody work out. Completed till here. Any doubt? Mr. Pradeep? Rohit? Vanu and Samaya? Doubt erga, please ask me. Are you clear, everybody? So we got it now, two equations. So totally, what is the first equation? 2GH is equals to V2 square minus V1 square. And second equation, V2 by V1 is equals to A1 by A2. Any problem, guys? Yes, please. All of you? Yeah. So now let me go back to there. So there I'll teach you. So it is easy for me. So here means we can solve. So we got two equations. So from the first equation, right? What is the first equation? Tell me, everybody. V2 square minus V1 square is equals to 2GH. Any problem? Yes? Okay, everybody? Now,
Yes, sir.
let me take divide this whole equation, this entire thing, this one, with the V1 square. V1 I will write it. So what will happen? I'll divide with the V1, or else, like that's what, multiply and divide with the V1. So what will happen, everybody? I'm multiplying and divide with the V1, or else you take it to V1 outside. So I'll take the common V1 square. So if I take the V1 square common, can you tell me what will happen? Anybody? So I'm taking V1 square is common. So what else will be inside? Anybody? V2 square divided by V1 square minus 1. Is it okay, Rudresh? Understand, Laksha? I'm taking V1 square common. Okay,
Yeah.
everybody? Yes, please. All of you. Again, if you multiply, you'll get the same thing. If you multiply, you'll get the same thing. Now, so I will write this one as V1 square is equals to, here you see that, V2 divided by V1 whole square minus 1, which is equals to 2GH. So now if you, by this time your mind should say something. What is that? We have got just from equation of continuity, V2 by V1 is equals to something. Anybody? What is that? A1 by? In place of V2 divided by V1, I'll write V1 square into, in place of V2 divided by V1, what I can write? A1 divided by A2 whole square minus 1 is equals to 2GH. Any problem? All of you? Clear? So now you see that V1 square is into, I will take it as this one again individual, A1 square divided by A2 square minus 1, which is equals to 2GH. So V1 square is into this one, A1 square minus A2 square divided by A2 square is equals to 2GH. Now I want V1 square formula. Anybody can tell V1 square formula? V1 square is equals to, A2 square will come this side, it will become 2GH into A2 square divided by, this one is multiplication, will come this side, it will become multiplication, division. So now from this, V1 is equals to root over 2GH into A2 square divided by A1 square minus A2 square. So this square is applicable for both. So A2 square and root will get cancelled. So I'll write the answer A2 into root over 2GH divided by A1 square minus A2 square. Up to here, anyone having any doubt, you can ask me. I'll explain you. Otherwise, you can proceed further. Any doubt, guys? Understand? Yes, everybody? Clear? So, this is only call it as a calculating velocity at V1. So I got V1 now. Suppose if you want to get to V2, so it's very simple. So V1 means what is the formula you got it? V1 is equals to A2 into root over 2GH divided by A1 square minus A2 square. Now, if you want it for V2, so same way you can solve it. So what will happen, everybody? V2 is equals to, can you tell me? Same way, V2 is equals to what will happen? Instead of A2, what will happen? A1 will come, remaining all same. So 2GH divided by A1 square minus A2 square. So please learn, everybody. So V1 and V2 formulas. This is what we used to call the most important formulas of Venturimeter. Calculating V1 and V2. Any doubt, anybody can ask me. I will proceed further. Clear, everybody? Understand, everyone? Yes, please. That is it. So solve it. V1, V2, I found it now. So just now we studied the today's class. What do you mean by rate of flow? Rate of flow means what? Everybody? What do you mean by rate of flow? Area into. What do you mean by rate of flow? Everybody? Rate of flow means what, guys? Area into velocity. So I will make it first one. A1, V1. And another one is what? A2, V2. So first I'll write A1, V1. So A1, V1 is equals to A1 into, what is the V1? V1, check it, everybody. What is the V1? Say formula. V1 is equals to what? A2 into root over 2GH divided by A1 square minus A2 square. Same way, A2 V2 is equals to, what is the formula? A2 into, what is the V2 formula? V2 formula, A1 into 2GH divided by A1 square minus A2 square. So this is what is the most important thing. So now again, if you want to get it, sir, what is rate of flow? So rate of flow A into V is equals to rate of flow. Rate of flow. Now you want to get it V1 and V2. Let me take this is A1 and V1 is equals to rate of flow. So I want it V1. V1 is equals to what? Everybody. A rate of flow divided by A1. And I want it V2. V2 is equals to what? Everybody. Rate of flow divided by, yes please. Rate of flow divided by what will come? A2. So if you want to do it, what is the A1? Rate of flow? A1 A2 into root over 2GH divided by A1 square minus A2 square divided by A1. A1 get cancelled. Again you'll get the same formula. Same way here. A1 into A2 into root over 2GH divided by A1. Yeah, this root is for full. Please make it. So divided by, what will happen? A1 square minus A2 square. So divided by A2. So A2 will get cancelled. Again, you'll get the same formulas. So that is what we used to call it as rate of flow. So rate of flow, velocity is equals to rate of flow divided by area. So please learn it. It's very important. I hope you all understanding, everybody. Any doubt, anybody can ask me. Clear, guys? All of you? Yes?
Yes.
Yes, sir.
Yes, sir.
Any doubt, anybody can ask. So this is what we used to call it as a applications of Bernoulli's principle, and in the first device call it as Venturimeter. So I hope anybody having any doubt, you can ask me, or else we'll proceed further. Do it quick. Who is missing? Narayana and Vinci. Yeah, make it fast, everyone. Any doubt, guys? Clear, everybody? Mr. Rafael, Rishi, understand Rishi? Murali?
Yes, sir.
Yeah. So next one is the second one, as I told you, that is what speed of efflux. Speed of efflux, which we also we can call it as a, basically, what does it call it as? I told you. Torricelli's theorem. Okay. So Torricelli's theorem or principle. So whatever it is. So now basically, so before going to explain you this all, so I want to teach you one thing. So like for example, you are having a water bottle. All of you consider. Now it is fully filled with the liquid. Now the total height of the liquid is h. All of you observe. And somewhere I made a hole so that water is started coming out from the hole. So up to where the water will be drained out, up to this height the water will be drained out. Am I right? Everybody? Yes, please. If I make the hole here, up to this height the water will be drained out. Means the water is actually from here to here the water is completely will come out. Means when the time is, suppose if I make a hole here, when the time is keep on going, the height of the water will be keep on decreases or increases or remains constant. Anybody? So initially water may be up to here. After 1 second reduces to here, up to here, next reduces here, next reduces here, next reduces here. So height of the water is decreasing or increasing? Everyone? I'm asking you, decreasing or increasing? The height of the water, let me take the total height is capital H. Initially, before hole, the total height is capital H. Now, as soon as I made the hole, the height of the liquid is small h. Now, capital H, the total height of the liquid remains constant. It's not going to change. But if I make the hole at this point, so then the height from the hole to the top is small h. Now, do you think this small h remains constant or this small h varies? Anybody?
Varies.
Yes, please.
Varies.
It will be start varies because when the time increases, so when the time is keep on going, so that the amount of fluid keep on will be pushing downwards, so that this liquid will be pushing outwards. So that is what will happen. So that is only Torricelli's laws. We are going to make it now. So let me consider there is a container. Everyone, there is a container. So we have been made a small opening for this. So let me draw that first. So again, I'm drawing. So there is a small container which is fully filled with the liquid. Just imagine it is fully filled with the liquid whose area of cross section is A. Okay, va? So whose area of cross section is A? Clear? Or A1? This is surface 1. Now it is experiencing by some pressure. Can you tell me what is that pressure? Call it as? It is experiencing by some pressure. What is atmospheric pressure? Now we have been made a very, very minute hole at a certain height. A minute hole where area of cross section is A2. This is the point number 2. So what will happen? The liquid will be started coming out forcefully. So now see that when this, if it is opening, then here also it will experience some pressure. What is that pressure? Everybody? Yes, please. Atmospheric pressure. And you see, as soon as if I made a hole, the water will moving fast outside. Let me take that velocity is V2. So if this liquid is moving outside, definitely the liquid up here will start coming down. That is what, let me take V1 velocity. Any problem for anybody? Do you all understand, everybody? Yes, please.
Yes, sir.
That's all. So now you know velocities, you know pressure, and you know densities. Density remains constant. So can you tell me the Bernoulli's equation, everybody? Bernoulli's equation is what? P1 is equals to, respond, sorry, P1 plus
Rho GH.
P1 plus
Rho GH.
plus half into rho V1 square is equals to P2 plus rho G, let me write it, H plus half into rho into V2 square.
Half rho V2.
So let me take the total height of this fluid, which is before hole is capital H. Now the height after making the hole, let me consider as a small h. Purima? Now, all of you observe, as we know, both places it is experiencing the pressure is atmospheric pressure only. So I can say P1 is equals to P2, which is equals to P0. So that both P1 and P2 will get what? Both P1 and P2 will get? If you say only, it will be beautiful. P1 P2 will get what? Cancel. Am I right? For those understand or not? Yes? Now, rho GH, initial height is H only, where at V1, in this case. So the height of the liquid above from the hole is H. But if it, rho GH plus half into rho into V1 square is equals to, here you observe that, at point 2, what is the height of the liquid? At point 2, what is the height of the liquid? H is equals to, point 2, what is the height of the liquid? Height above from the liquid is baseline, guys. That is a baseline. So if I take this is the baseline, so V1 point is at H height and V2 point is at the same line. So if it is the same line means what is the height? Yes, please, baseline. It is on the same baseline. So if I consider, so what is the height? 0. So understand, everybody? So rho G 0 H plus half into rho V2 square. So now this term also will become 0. So what else remaining? Rho GH plus half into rho V1 square is equals to half into rho into V2 square. Okay, understand, everybody? Now, here, keep it in mind, the Torricelli's theorem or speed of efflux, EFF-LUX, efflux is applicable only, it is true, only when the given assumption is true. So if I consider, assume this assumption, if you consider only this Torricelli's theorem is true, otherwise it's not, please remember. So as you all notice it, the big container having a very extremely small opening. So this area is A2 and this area is A1. So if you notice it, A2 is extremely smaller than A1. Am I right, everybody? Yes, please. So we all knows that if area increases, velocity is what? Area increases, velocity is what? All of you? Yes, please. Decreases. Now, if I compare it, actually, if A2 is extremely smaller than A1, then definitely the velocity of A1 is almost negligible compared to V2. Am I right? Will you all agree with me? Yes, please. All of you respond, Ra. If you say responsible. So I'm considering V1 is equals to 0. Assume, this is the assumption. Assumption is A2 is smaller than A1, and where V1 almost the velocity of coming down will become 0 because of area increases, velocity decreases. So they are moving with the velocity V2 horizontally. So that is you have to remember, x-axis. Okay, wow. Understand, everyone? Yes, please.
Yes.
Yeah, that is what. So then you all speak, what will happen? Then after this one, so after this assumption, you have to remember this assumption. Without this, Torricelli's theorem is not true. So what will happen? Rho GH is equals to half into, okay, so because V1 will become 0, I assumed as a, what is my assumption? V1 will become what? 0, because A2 is extremely smaller, so that we will get rho GH is equals to half V2 square. Okay, so now rho will get cancelled. So from that I will get V2 square is equals to 2GH. V2 square is equals to 2GH. From that, V2 is equals to root over 2GH. So this V2 is only, we used to call it as a Torricelli's equation. So please all of you write it. So Torricelli's equation is equals to, under assumption, very, very important. Under assumption, what is the assumption, everybody? Without that assumption, it is not true. What is that assumption, everybody? A2 is extremely smaller than A1 and V1 is approximately consider what? Approximately consider 0. So under this assumption, the velocity, that is what Torricelli's theorem. So this is only call it as a Torricelli's theorem. So which is basically will says that velocity which is leaving the fluid, which is equals to root over 2GH. So that is what you have to remember. Understand, everybody? So now, sir, this formula is already, we have been studied under gravitation chapter also. So under gravitation, you might be remember, when any body is falling freely towards the ground, what is its initial velocity? If object is freely ready to fall to, initial velocity is what, everybody? 0. Let me consider the distance covered by it is h. And before touching the ground, what is the final velocity? Everybody? Maximum. And acceleration due to gravity is equals to z. So by using third equation of motion, v square minus is equals to 2as. That is what I will take 2gh. So from this you see, as initial velocity is 0. So velocity, final velocity is equals to 2gh. Now velocity is equals to root over 2gh. That is only Torricelli's theorems. The same formula, same thing. I hope you all understand, everybody. What we have done, that is only the Torricelli's theorem. Okay, guys? All of you? Yes, please respond.
Yes.
So that is what it is. So till here you learn. Anybody having any doubt, you can ask me, or else we'll make it now. So there is a most important concept. That is what you can see. I won't teach you that now, but I will explain you the concept. Now you all observe very carefully, as I already taught you at the beginning. So now let me take one hole if we make, okay. So totally the liquid is completely filled container. Now if you all notice 8th class experiment, the total height of the liquid is, let me take it as a capital H. Now Mr. Pradosh made 3 different positions. He made 3 different holes. Now tell me, for this first hole, let me take P1. This is P2 and P3. Which is greater, everybody? You all people know, depth increases, definitely pressure will what? Increases. So P3 is greater than P2 is greater than P1. Will you all agree with me, everybody? Yes. Now you tell me, for P1, if you notice it, for this baseline, let me take that height is H3. For P2, for this baseline, H2. For this P1, for this baseline is H1. So now if you notice it, H3 is greater than H2 is greater than H1. So that is why the P3 is greater than P2 is greater than P1. Because depth increases, then the pressure is also what? Depth increases, then pressure is also increases. Now, If this 3 holes is removed at a time, suppose he has been sealed initially. Now these 3 holes will be removed at a time. Now tell me in which hole the water will be displaced to a long range. Like that is what parabola. If I make here, maybe they will fall near to the bottle. If I make here, maybe they may fall little bit far. If I make here, definitely they will fall little bit far away from the jar or a beaker. Am I right, everybody? You might be remember this activity now, 9th, 8th class. Yes, please. All of-
Yes, sir.
So now, how much it is displacing from this when you make the different, whatever the positions, if you see. So if I take the first hole, initially the liquid height is this much, h. Now after 1 second decreases, after 1 second decreases, after 1 second decreases, then first hole over. So now that is why this h is not remains constant. What is this, everybody? H is always remains. All of you, h is remains. Varies, but the total height of the liquid at initially is, let me take capital H. And the area of displacing, if you see, so if you notice it, compared to the area of cross section, the area of displacing to the area of cross section is extremely smaller. If I take 1, so sorry, yeah, A1 is very, very bigger than A2, or A2 is extremely smaller than A1. Then we have been made an assumption. I told you. What is that assumption? Anybody? V1 is equals to what? All of you. V1 is equals to
0.
0. Purima? No. So how much it is displacing from the container? So you might be remember, this is looks like some motion. Anybody can tell? What is that motion? Call it as? Yes, please. If you fire a gun, if you fire a bullet, or if you have been done. Suppose if I have been thrown the ball with the velocity u, then it has been goes and come back. So the distance is to call something. Yes, Pradosh, initial point and final point. Anybody?
Horizontal range.
Horizontal range. So that is only very important concept. So for the formula for the horizontal range, how to calculate it, everything we'll discuss tomorrow's class. So now that path, what is it path we used to call it as? All of you? Yes, please. It will
Parabolic.
take a parabolic path and it's a motion called some motion. If I've been thrown a ball like this, it will come up.
Projectile.
All of you? Projectile.
Projectile motion.
Okay. So what is this? And what is the range formula? Anybody can tell? That is only we are going to calculate. Range is equals to what? Horizontal velocity into something. Anybody? Horizontal velocity time. So horizontal velocity we know. What is the horizontal velocity?